Hello, smart learners of Study Studio. Welcome back to your one-stop channel for exam-focused learning. Today, we're unlocking a high-value topic that's crucial for UPSC and SSC aspirants, Cyclone Mocha. More than just a current affair, it's a living case study connecting geography, disaster management, and climate change. Cyclone Mocha was one of 2023's most powerful storms, and if you're prepping for the UPSC or SSC exams, you need to understand it inside and out. In this video, we're going to break down everything that matters. We'll cover the essential prelims facts for quick marks, the deep analysis needed for a high-scoring mains answer, and we'll even run through some practice MCQs at the end so you know you've got this. Think of this not just as a current affairs update, but as a complete case study for your GSI Geography and GS3 Disaster Management papers. Let's break it down. Before we get into the complex science and the mains level analysis, let's lock down the basic facts. What exactly was Cyclone Mocha? And what's its story? The story starts on May 8, 2023, with a low-pressure area bubbling up over the southern Bay of Bengal. Over the next couple of days, this system steadily got its act together, strengthening into a depression and then, on May 10, officially becoming a cyclonic storm. That's when it got its name, Mocha. The name was suggested by Yemen, a nod to the historic Red Sea port city famous for its coffee trade. From there, Mocha put on a masterclass in what meteorologists call rapid intensification. It tracked north-northwest, feeding on the exceptionally warm waters of the Bay of Bengal. The India Meteorological Department, or IMD, soon classified it as an extremely severe cyclonic storm. By May 14, it reached its terrifying peak, with wind speeds touching 270 km per hour, making it a Category 5 equivalent cyclone, the absolute top of the scale. This incredible power put it in a tie with 2019's Cyclone Fani as the strongest cyclone recorded in the North Indian Ocean since the satellite era began in 1982. On the afternoon of May 14, Cyclone Mocha made landfall, slamming into the coast of Myanmar's Rakhine state near the city of Sittwe. As it moved over the rugged inland terrain, it was cut off from its fuel source, the warm ocean, and quickly began to fall apart. But by then, the damage was done. It left a horrifying trail of destruction, not just in Myanmar, but also hitting parts of Bangladesh and causing heavy rainfall in Indian states like Mizoram, Tripura, and Nagaland. For any serious aspirant, knowing what happened with Cyclone Mocha is only half the job. You have to connect it to the why. This is where your GSI Geography syllabus comes to life. So, what are the ingredients needed to cook up a monster storm like a tropical cyclone? There are a few critical conditions, and Mocha ticked every single box. First, and most critically, you need a huge patch of warm ocean. The general threshold is about 27 degrees Celsius. In May 2023, the Bay of Bengal wasn't just warm, it was scorching. With sea surface temperatures hitting 30 to 32 degrees. This is a direct footprint of global warming, since our oceans have soaked up over 90% of the planet's excess heat. This heat is the cyclone's fuel. It causes massive evaporation, creating a huge supply of warm, moist air. Second, you need the Coriolis force. That's the spin created by the Earth's rotation, which gives a cyclone its classic vortex structure. This force is almost zero at the equator, which is why cyclones form in the belts between 5 and 30 degrees latitude, but not right on the line. Third, you need a pre-existing weather disturbance, like the low-pressure area where Mocha began. As that warm, moist air from the ocean surface rises, it cools and condenses, which releases an enormous amount of energy called the latent heat of condensation. This heat warms the surrounding air, making it rise even faster, which in turn creates an even stronger low-pressure area below. It's a powerful, self-sustaining feedback loop. Fourth, you need low vertical wind shear. Imagine wind shear as winds blowing at different speeds or directions at different heights. High shear will rip a budding cyclone to shreds. Low shear, however, allows the storm's vertical structure to grow tall and organized. And finally, you need something called upper-level divergence. At the top of the storm, the air needs to spread out. Think of it like a chimney flue being opened wide, which helps pull more warm, moist air up from the bottom and intensifies the entire system. Now, a key term you must know from the Mocha case study is rapid intensification. This is when a cyclone's wind speed explodes in a short amount of time, officially, an increase of 55 km per hour in under 24 hours. Mocha did this spectacularly. In the past, this process would take much longer. But those record high sea surface temperatures gave Mocha the super fuel it needed for this explosive growth. This trend of rapid intensification is becoming a dangerous signature of cyclones in the era of climate change. Another feature seen in powerful storms like Mocha is an eye wall replacement cycle. The eye is the calm center, surrounded by the eye wall, where the winds are most violent. In monster cyclones, a new, outer eye wall can form, which then tightens and replaces the original inner one. This process can make the storm's intensity fluctuate for a bit, but it's a clear sign of a mature and extremely powerful system. Understanding these mechanics is your key to seeing Cyclone Mocha not as a random event, but as a real-world demonstration of the geographical principles in your textbooks. Let's shift gears to the core of your mains prep, the GS3 disaster management analysis. Here, we have to dissect the impacts, evaluate the response, and look at the bigger policy picture. Cyclone Mocha is a fantastic case study because it offers such stark contrasts. First, the impact analysis. The devastation was staggering. The humanitarian impact was a nightmare. An estimated 3.4 million people were directly in the cyclone's path. While Myanmar's military government reported around 145 deaths, the country's national unity government stated the number was far higher, at over 460, with hundreds more missing. The storm displaced hundreds of thousands of people from their homes. The infrastructural impact was catastrophic. Across Myanmar's Rakhine, Chin, and Sagaing states, more than 158,000 buildings were damaged or just obliterated. This included thousands of homes in the deeply vulnerable Rohingya refugee camps. Schools, hospitals, and communication towers were flattened, crippling entire regions. The economic impact was just as bad. Livelihoods were wiped out. The agriculture and fishing sectors, the backbone of the coastal economy, were devastated as crops were ruined, farmland was flooded with salt water, and fishing boats were lost. This triggered sharp food shortages and price hikes, shattering the economy of an already fragile region. The World Bank put the price tag for direct damage in Myanmar at a mind-boggling $2.24 billion. For a top-tier UPSC answer, you must highlight the disproportionate effect on vulnerable populations. Cyclone Mocha was a disaster layered on top of a long-running humanitarian crisis. The Rohingya refugee camps in both Bangladesh and Myanmar, with their flimsy shelters, were hit hard. In Bangladesh, while casualties were minimal, thousands of shelters in Cox's Bazar were damaged. The situation in Myanmar was far worse. The cyclone also made the threat from landmines in conflict zones even greater, as floodwaters can shift their locations, and it created the perfect conditions for outbreaks of waterborne diseases like cholera. Now, let's analyze the disaster management response, which is a tale of two completely different stories. This is perfect for a comparative analysis in your mains answer. On one hand, you have Bangladesh, a genuine success story in cyclone preparedness. Having learned brutal lessons from past cyclones, Bangladesh has built a world-class disaster management framework. Before Mocha even arrived, the government launched a massive evacuation campaign, successfully relocating hundreds of thousands of people from coastal areas to hardened cyclone shelters. The Cyclone Preparedness Program, a brilliant network of community volunteers, was incredibly effective at spreading warnings and helping people move to safety. Thanks to these proactive measures, Bangladesh reported no direct loss of life from the storm, a truly remarkable achievement. On the other hand, you have Myanmar, where the story is far more tragic. Initial evacuation efforts did move over 137,000 people. However, the post-disaster response was crippled by political gridlock. After the storm, Myanmar's military administration imposed severe restrictions on travel and the distribution of humanitarian aid. These blockades effectively halted relief operations by the UN and other international NGOs. Aid workers were blocked from reaching the hardest-hit areas, causing massive delays in delivering food, clean water, and shelter. This highlights a crucial point for your analysis. A disaster response isn't just about technical capacity, it's shaped by the governance context. Making matters worse, the humanitarian appeal for Mocha was critically underfunded, receiving only a tiny fraction of what was needed. Finally, you have to connect this to the climate change angle. This is the thread that ties it all together. The science is clear: a warmer planet is brewing more dangerous cyclones. As we covered, the main reason for Mocha's explosive growth was the record hot surface of the Bay of Bengal. Climate models show a clear trend in the North Indian Ocean, while the total number of cyclones might be stable or even slightly decreasing. The frequency of very severe and extremely severe cyclones is going up. Storms are getting stronger, faster. For your GS3 answer, this means you need to talk about an integrated approach. First, better science for forecasting, especially for rapid intensification. Second, massive investment in climate-resilient infrastructure, stronger homes, elevated shelters, and protecting natural barriers like mangroves. Bangladesh's investment of over $10 billion in coastal defenses and shelters is a prime example. Third, we need policies focused on proactive preparedness and risk reduction, not just reactive relief. Cyclone Mocha is a flashing red light, warning us of the escalating costs of inaction in a warming world. Okay, time to boil all that down into a rapid-fire revision list, perfect for your prelims. These are the facts you absolutely need at your fingertips. Name: Cyclone Mocha. Named by Yemen. Type: extremely severe cyclonic storm, per IMD. Peak wind speed, reached up to 270 km per hour, a Category 5 equivalent storm. Area of origin: Southern Bay of Bengal. Landfall: May 14, 2023, near Sittwe on the Rakhine coast of Myanmar. Historical significance: tied with Cyclone Fani, 2019, as the strongest cyclone in the North Indian Ocean since 1982. Primary reason for intensification: exceptionally high sea surface temperatures in the Bay of Bengal, 30 to 32 degrees Celsius. Key areas affected: primarily Myanmar, Rakhine State, and Bangladesh, Cox's Bazar, with rainfall in northeast India. Naming convention: named by member countries of the WMO ESCAP panel. Memorize these. They are high-value targets for MCQs. Alright, let's see what stuck. I'll give you 4 potential prelims questions. Pause, think it over, and then I'll reveal the answer and why it's correct. Question 1. Cyclone Mocha made landfall on which coast with Category 5 equivalent intensity? A. Orissa, India. B. Rakhine, Myanmar. C. Cox's Bazar, Bangladesh. D. Andaman Islands. The correct answer is B. Rakhine, Myanmar. As we discussed, the eye of the storm hit the coast of Myanmar's Rakhine state on May 14. Question 2. What was the primary meteorological factor that fueled Cyclone Mocha's rapid intensification in May 2023? A. A strong Madden-Julian oscillation only. B. Exceptionally high Bay of Bengal sea surface temperatures of 30 to 32 degrees Celsius. C. The onset of the Arabian Sea monsoon trough. D. An unusually strong equatorial Rossby wave alone. The correct answer is B. Bay of Bengal SSTs of 30 to 32 degrees Celsius. While other atmospheric factors helped, the extraordinary ocean heat content was the critical fuel for its explosive growth. Question 3. Which factor most significantly hampered the post-cyclone humanitarian aid efforts in the worst affected regions of Myanmar? A. A complete lack of early evacuations. B. Military-imposed restrictions on aid delivery and travel. C. Insufficient and inaccurate weather forecasting. D. The fact that no Rohingya camps were affected. The correct answer is B. Military restrictions on aid delivery. As we analyzed, the administrative blockades after the storm were the single biggest obstacle to getting aid to people in need. Question 4. Cyclone Mocha is tied with which of the following storms as the strongest recorded in the North Indian Ocean since 1982? In terms of wind speed? A. Cyclone Amphan, 2020. B. Cyclone Fani, 2019. C. Cyclone Taukte, 2021. D. Cyclone Nisarga, 2020. The correct answer is B. Cyclone Fani, 2019. Both Mocha and Fani hit similar peak intensities, making them the most powerful storms in the basin in modern records. So, what's the bottom line? Cyclone Mocha isn't just a headline. It's a living, breathing case study that weaves together geography, disaster management, governance, and climate change. For your exams, lock in these three key takeaways. The science behind its formation, especially the role high sea surface temperatures played in its rapid intensification. The powerful contrast in disaster management between Bangladesh's proactive success and the governance challenges in Myanmar. The undeniable link to climate change, which is making these extreme weather events stronger and more common. Master this topic, and you'll be ready for a whole range of questions in both prelims and mains. It could even give you killer points for an essay paper on climate change or disaster management. If this breakdown helped you, hit that subscribe button and ring the notification bell so you never miss our deep dives into crucial exam topics. Our job is to help you ace your exams with content that is clear, comprehensive, and straight to the point. Thanks for watching. Let us know in the comments what topic we should tackle for you next. Keep up the hard work, and we'll see you in the next video.